Good morning. I think we discussed two problems in the previous class. This problem and this problem. Correct? We finished two problems.
Yes, sir.
Okay. Next one. Third one. You can expect one problem of this kind in the examination. The joint distribution of two random variables x and y is given by this table. The joint distribution of two random variables, and there is a bifurcation like this. X takes two values 1 and 2, y takes three values 2, 3 and 4. The joint distribution of two random variables x and y given by this table. Determine the marginal distributions of x and y. Also verify whether x and y are independent. First, let's perform this part. Writing the marginal distributions. First, I prefer to write marginal distribution of x. X f of x. Here x takes two values, 1 and 2. X takes two values, 1 and 2. Correspondingly, when x is equal to 1, 0.06 plus 0.15 plus 0.09. What is the sum? It must be 0.3. When x is equal to 2, 0.14 plus 0.35 plus 0.21 is 0.7. Each of these two functional values are greater than 0 and their sum is equal to 1.3 plus 0.7 is 1. This is called marginal distribution of x. Next, marginal distribution of y. F y and g of y. Here y takes three values 2, 3 and 4. 2, 3 and 4. Corresponding to these two, we have 0.06 plus 0.14. 0.06 plus 0.14 is 0.2. Corresponding to this 3, we have 0.15 plus 0.35, that is 0.5. Corresponding to this 4, 0.09 plus 0.21, that is 0.3. All these functional values are greater than 0 and their sum is equal to 1.2 plus 0.5, 0.7. 0.7 plus 0.3 is 1. This is called marginal distribution of y. Now let's verify whether x and y, the random variables x and y, are independent or not. They are said to be independent if f of xi into g of yj is equal to jij. If this expression is satisfied for all these possibilities, then we say that the random variables x and y are independent. Let's check. 0.3 into 0.2. 0.3 into 0.2. 0.3 into 0.2. This is equal to 0.06. This is right. Next, 0.3 into 0.5. 0.3 into 0.5. This is equal to 0.15, right? 0.15, correct. Next, 0.3 into 0.3. 0.3 into 0.3. This 0.3 into 0.3. Clearly, this is equal to 0.09, same as this value, 0.09. Now start from this 0.7. 0.7 into 0.2. This is equal to 0.14. same as this value. Next 0.7 into 0.5. 0.7 into 0.5. Clearly this is equal to 0.35, same as this value. Next 0.7 into 0.3. This is equal to 0.21, same as this value. Therefore, for all the possibilities, this expression is verified. F of xi into g of yj is equal to gij is verified. Therefore, the random variables x and y are independent. They are independent. So please make a note of this. Next one. The joint distribution of two random variables x and y is given by this table. Find a marginal distribution of xy, covariance of xy. First, we shall find marginal distribution of x and y, particularly x. Here x takes two values, 1 and 3. Right? X takes two values, 1 and 3. Correspondingly, when x is equal to 1, we have 0.1 plus 0.2 plus 0.2, that is 0.5. When x is equal to 3, 0.3 plus 0.1 plus 0.1 is 0.5. Clearly, these two are greater than 0 and their sum is equal to 1. This is what we call marginal distribution of x. Similarly, marginal distribution of y. Here y takes three values, minus 3, 2, and 4. Corresponding to this minus 3, 0.1 plus 0.3, two functional values, 0.1 plus 0.3, 0.4. Corresponding to this 2, 0.2 plus 0.1, 0.3. 0.2 plus 0.1, 0.3. Each of these three functional values are greater than 0 and their sum is equal to 1. This is marginal distribution of y. Now we find a covariance of xy. Covariance of the two random variable xy. This is given by expectation of xy minus expectation of x, e of x or mu x into mu y. That means mu x is to be determined, mu y is to be determined, and e of xy is to be determined. First, we find e of x. This is given by summation x to f of x. Calculate this x into f of x. 0.1 into, I'm sorry, here 1 into 0.5 plus 3 into 0.5. 1 into 0.5 plus 3 into 0.5. No calculator is required. 3 into 0.5 is 0.5 plus 0.5 plus 0.5, 1.5 plus 0.5, 2. This is mu x. Similarly, expectation of y. This is equal to summation y into g of y. This is equal to minus 3 into 0.4 plus 2 into 0.3 plus 4 into 0.3. Do it.
0.6.
0.6. 4 into 0.3 minus 4 into 0.3 will get cancelled. 2 into 0.3 is 0.6. Next summation, expectation of xy. It is given by summation xi into yj into jij. You consider this one. 1 into minus 3 into 0.1 plus 1 into 2 into 0.2 plus 1 into 4 into 0.2 plus 3 into minus 3 into 0.3 plus 3 into 2 into 0.1 plus 3 into 4 into 0.1. The answer
0.
0. Right. Now substitute here. Covariance of xy is equal to expectation of xy is 0 minus expectation of x is 2 into y is 0.6. This is equal to minus 1.2. Minus 1.2. So please make a note of this, and for your doubts, you can unmute. Is this clear?
Yes, sir.
Okay, we can move to the next problem. You note down this problem for homework. You try this one by yourselves at your home. If you find any doubts or difficulty, you can ask. The joint probability distribution of two discrete random variables x and y is given by the table. The table is specified. Determine the marginal distributions of x and y. Also find whether x and y are independent. You keep this problem for homework. Suppose x and y are two independent random variables with the following respective distribution of x and y. Also verify that covariance of x and y is equal to 0. This is the problem. Suppose x and y are independent random variables with the following respective distributions. Respective distributions means this is a distribution of x. That's what we call marginal distribution. This is marginal distribution of x and this is marginal distribution of y. First, we shall write the joint probability distribution of x and y. Let's construct the table. X, y. Here x takes two values, 1 and 2, and y takes three values, minus 2, 5, and 8. These are the values attained by y. And it is given that x and y are independent random variables. Therefore, 0.7 into 0.3 must be J11. 0.7 into 0.5 must be J12. 0.7 into 0.2 must be J13. This will constitute the first row. Similarly, 0.3 into 0.3 must be J21. 0.3 into 0.5 must be J22. 0.3 into 0.2 must be J23. This will constitute the second row. Therefore, 0.7 into 0.3. 0.7 into 0.3. 0.21. Right. Next, 0.7 into 0.5. 0.35. 0.7 into 0.2. 0.14. 0.3 into 0.3. 0.09. 0.3 into 0.5. 0.15. 0.3 into 0.2. 0.06. This is the joint distribution table. Joint distribution table. Now verify that covariance of xy is equal to 0. Let's find the covariance. What is the expression to find covariance? It is given by covariance of xy is given by expectation of xy minus mu x mu y. Correct? Now we find the expectation of x first, which is given by summation x into f of x. You do it and let me know the values. Expectation of y is summation y into g of y. Summation x into f of x. Use this table of x, marginal distribution table of x. 1 into 0.7 plus 2 into 0.3.
1.3.
1.3, that's right. 1.3. Next, expectation of y, minus 2 into 0.3 plus 5 into 0.5 plus 8 into 0.2.
3.5.
3.5, that must be correct. Next, expectation of xy. Expectation of xy. Use this joint distribution table for this. 1 into minus 2 into 0.21 plus 1 into 5 into 0.35 plus 1 into 8 into 0.14, 2 into minus 2 into 0.09, 2 into 5 into 0.15, 2 into 8 into 0.06.
$4.55.
Right, 4.55, that's correct. 4.55. Now let's find the covariance of xy. Substitute. Expectation of xy is 4.55 minus mu x is 1.3. Mu y is 3.5. Check it.
0.
0. That's fine. So please make a note of this. Next problem. X and Y are independent random variables. X takes values 2, 5, 7 with probability 1 by 2, 1 by 4, 1 by 4 respectively. Y takes values 3, 4, 5 with probability 1 by 3, 1 by 3, 1 by 3. Find the joint probability distribution of XY. Show that the covariance of XY is equal to 0. Find the probability distribution of Z is equal to X plus Y. First, we shall establish joint probability distribution of XY. Let's write this first statement mathematically. X and Y are independent random variables where X takes values 2, 5, 7. X takes values 2, 5, 7. They are tabulated here. 2, 5, 7. Corresponding probabilities are 1 by 2, 1 by 4, 1 by 4. So here 1 by 2, 1 by 4, 1 by 4. This is what we call marginal distribution of X. Next, Y takes three values, 3, 4, and 5. Corresponding probabilities are 1 by 3, 1 by 3, 1 by 3. This is marginal distribution of Y. This is the given statement. Now we shall establish the joint probability distribution of X and Y. Let's construct the relevant table for this. This is for X and this is for Y. Here X takes three values, 2, 5, 7, and Y takes three values, 3, 4, and 5. 3, 4, and 5. It is given that X and Y are independent random variables. Therefore, 1 by 2 into 1 by 3 is J11. It must be here. That is 1 by 2 into 1 by 3 is 1 by 6. 1 by 2 into 1 by 3 is 1 by 6. Again, 1 by 2 into 1 by 3 is 1 by 6. Next, 1 by 4 into 1 by 3 is 1 by 12. 1 by 4 into 1 by 3 is 1 by 12. 1 by 4 into 1 by 3 is 1 by 12. 1 by 4 into 1 by 3 is 1 by 12. Again, 1 by 4 into 1 by 3 is 1 by 12. And here 1 by 12. This is joint probability distribution of the random variables X and Y. Now show that the covariance of XY is equal to 0. Now we shall find the covariance, which is given by expectation of XY minus expectation of X or mu X into expectation of Y or mu Y. Therefore, we first find expectation of X, which is given by summation X into f of X. Calculate this. X into f of X is 2 into 1 by 2 plus 5 into 1 by 4 plus 7 into 1 by 4. How much is this?
4.
4. Right. This is 4. Expectation of Y is summation Y into G of Y.
Four.
4, right. It is again 4. Next, expectation of xy. It is given by summation xi, yj, jij. Use this joint distribution table for this. 2 into 3 into 1 by 6 plus 2 into 4 into 1 by 6 plus 2 into 5 into 1 by 6 plus 5 into 3 into 1 by 2 plus 5 into 4 into 1 by 12 plus 5 into 5 into 1 by 12, 7 into 3 into 1 by 12 plus 7 into 4 into 1 by 12 plus 7 into 5 into 1 by 12.
Sixteen.
16, that's right. 16. Now substitute here. Covariance of xy is equal to expectation of xy is 16 and that of x is 4 and y is 4. Clearly this is 16 minus 16, 0. That's what we require. Show that the covariance of x and y is equal to 0. So make a note of this. And then we take up this case, third case. You can mark your attendance now. Mark your attendance. Find the probability distribution of z is equal to x plus y. Z is equal to x plus y. First we construct the domain of this set. Possible values of this set. X plus y. These are the values attained by x and these are the values attained by y. 2 plus 3, 5. 2 plus 4, 6. 2 plus 5. 7. 2 plus 3, 5. 2 plus 4, 6. 2 plus 5, 7. 5 plus 3, 8. 5 plus 4, 9. 5 plus 5, 10. 7 plus 3, 10. 10 is already there. We need not consider it again. 7 plus 4, 11. 7 plus 5, 12. Now write the corresponding probabilities. Corresponding probabilities. Corresponding to this 5. How is this 5 obtained? 2 plus 3. Corresponding probability is 1 by 6. 6. How is the 6 obtained? 2 plus 4. Corresponding probability is 1 by 6. How is the 7 obtained? 2 plus 5. Corresponding probability is 1 by 6. Next 8. Corresponding to this 8. 8 is obtained by adding these two. 5 plus 3, 8. Corresponding probability is 1 by 12. 5 plus 4, 9. Corresponding probability is 1 by 12. 5 plus 5, 10. Corresponding probability is 1 by 12. One more possibility is there. 7 plus 3 is 10 and corresponding probability is 1 by 12. Therefore, 1 by 12 plus 1 by 12 is 2 by 12. 2 by 12 is 1 by 6. 5 plus 5 is 10, corresponding probability 1 by 12, plus 7 by 3 is also 10, corresponding probability is 1 by 12. 1 by 12 plus 1 by 12 is 2 by 12, that can be written as 1 by 6. Next, 11. 7 plus 4, 11, corresponding probability is 1 by 12. 7 plus 5, 12, corresponding probability is 1 by 12. You make a note of this. The joint probability distribution of two discrete random variables x and y is given by f of x comma y is equal to k into 2x plus y, where x and y are such that 0 less than or equal to x less than or equal to 2. This is a closed interval, that means endpoints are included. 0 less than or equal to y less than or equal to 3. Here also endpoints are included. Find the value of k. Find the marginal probability distribution of x and y. Show that the random variables x and y are dependent. Here, x is such that 0 less than or equal to x less than or equal to 2. That means 0, x takes three values, 0, 1 and 2. Similarly, y is such that 0 less than or equal to y less than or equal to 3. That means y takes three values, 0, so 1, 2, 3, 4 values in fact. Y is equal to 0, 1, 2, 3. Now construct the table. This is y and this is x. X takes values 0, 1, 2. Y takes values 0, 1, 2, and 3. When x is equal to 0, y is equal to 0. This will be 0 plus 0, 0, 0 into anything is 0. When x is equal to 0, y is equal to 1. X is equal to 0, y is equal to 1. 1 into k is k. X is equal to 0, y is equal to 2. 2k. X is equal to 0, y is equal to 3. 3k. In the last column, we write sum. Next, when x is equal to 1, y is equal to 0. X is equal to 1, y is equal to 0. This will be 2, and 2 into k is 2k. X is equal to 1, y is equal to 1, 3k. X is equal to 1, y is equal to 2. X is equal to 1, y is equal to 2, 4k. X is equal to 1, y is equal to 3, 5k. X is equal to 2, y is equal to 0. X is equal to 2, y is equal to 0. This will be 2 into 2, 4. 4 plus 0 is 4. 4 into k is 4k. Here 5k. Here 6k. Here 7k. Zero plus 2k plus 4k is 6k, and here 9k, here 12k, and here 15k. and horizontally here 0 plus k plus 2k plus 3k is 6k, 14k, 22k. Since this is a discrete joint probability distribution, this sum must be 1 and this horizontal sum must be 1. This vertical sum must be 1. This horizontal sum must be 1. 6k plus 14k, 20k, 20k plus 22k is 42k. This is equal to 1. Therefore, k is equal to 1 divided by 42. You consider either of these two sums. You either consider this sum or this sum. Both will give you k is equal to 1 by 42. Therefore, the distribution table is now like this: x, y, 0, 1, 2, 3, 0, 1, 2, 0, k is 1 by 42, 2k is 2 by 42, 3k is 3 by 42, 2k is 2 by 42, 3k is 3 by 42, 4k is 4 by 42, 5k is 5 by 42, 4k is 4 by 42, 5k is 5 by 42, 6k is 6 by 42, 7k is 7 divided by 42. This is the joint distribution table now. Using this table, you can construct marginal distribution table. Marginal distribution for x and the marginal distribution for y. This part, I'll show you. This part, find marginal probability distribution of x and y. We are running out of the time. You do it by yourselves at your home. We have less than 1 minute left. Find the marginal probability distribution of x and y. You do it and show that the random variables x and y are dependent. Thank you.